All right, good afternoon. It's a pleasure to welcome you all again to another session where we come together under the banner of Code Without Barriers. This initiative is not just a program, it's a mission to reshape the tech industry by promoting diversity, inclusion, and opportunity for women in tech. Despite progress, women remain underrepresented in the fields like AI, cloud security. Programs like CWB aim to accelerate change. Since its launch in 2021, the program has achieved skilling over 38,000 women developers trained globally in AI, cloud, and security. Partnerships, onboarding partners to further drive Code Without Barriers mission in their organizations. Hackathons, over 45,000 participants worked over 63 impactful projects. Mentorships, 120 mentors guiding 1,000 mentees to build confidence and leadership. Community, 82 community partners for 112 events. Code Without Barriers in India has announced now. In India, the program is transforming lives. During his recent tour, Satya Nadella announced the goal of upskilling 75,000 women all across India, with over 35,000 already skilled. Today, let's celebrate these achievements and recommit to driving this mission forward. To help us dive into today's session on fundamentals of deep learning, we have Sheikh Ruxana, who is from Microsoft. She's a consultant at Microsoft. Over to you, ma'am.
Yeah, thank you, Kamya. So, hello everyone. So myself, Ruxana. I have around 8 years of experience in Microsoft, and I have been working with this uh, various technologies being in Microsoft. So today I'll be walking through the fundamentals of deep learning, which you can uh, deep into it later on and apply it in your projects wherever you are building it. So you guys are able to see my screen, right? Okay. So yeah, myself Ruxana, I'll be taking the session to you today. So let's start with the agenda. So I have I'm not going into deep because it might be difficult to you process. I'll give you a brief introduction to this. So I have what is deep learning. Then I'll be giving you a differentiation between AI and machine learning. Sorry, deep learning and machine learning. Then we'll go through some key concepts of deep learning and also some architects of deep learning and how the deep learnings will work, and then where we are using this deep learning in real world, and yeah, the end conclusion and question answer. So let me introduce with you what is deep learning first of all. So deep learning is a technology that allows computers to learn and make decision on their own, just like our human brains. So we see something, we decide and make decisions and predict what it could be, the outcome of that image. So instead of telling computer exactly what to do, so we show many examples and it learns from those examples to recognize the patterns and make predictions. So if you want a computer to recognize any picture, for example a cat, so you would show it thousands of pictures of cat and it would learn to identify them on its own. So basically, deep learning is a subset of machine learning, and it is based on some neural networks with many layers. So what is neural network? I'll talk about in the next slide. So now deep learning, as it is a part of artificial intelligence, it mimics the human brains and structures to recognize the patterns. So it also enables machines to learn from vast amount of data and make decision without explicit programming, like there will be no human interference there. So deep learning on its own will make the decision and predict the output. So one common example of deep learning is the application used in autonomous vehicle. So for example, nowadays we have these self-driving cars, right? So there we have used this deep learning. So it identifies the road sign, the predictions, the obstacles, to make the right decisions. Like if it is seeing any sign, like there can be some hump or some mountain is coming friend, so it will make the decision to slow drive. And also if any obstacle, it will uh, predict the perfect decision where it should stop or go, so like that. So this technology allows the vehicle to process large data. Like it is good at processing the large amount of data. And for example, in self-driving, we have used sensors and cameras which recognize the patterns, so that make real-time decision to navigate safely. So another example of deep learning is fraud detection. So nowadays in transaction we have this fraud coming up, right? So deep learning helps over there. It identifies unusual patterns and may indicate fraudulent activity. So by learning some past transaction based on that data, so the algorithm detect and prevent fraud more effectively. So how this deep learning has been evolved? It has been evolved from machine learning. In machine learning, you might have known this linear regression decision trees. So from there, the deep learning has breakthrough with the deep neural networks, especially they have graphic processing units and large data sets. So that's about deep learning introduction. Now I'll talk about the difference between machine learning and deep learning. Um, when we talk about machine learning, machine learning uses the algorithms to pass the data, and it learns from that data, make informed decisions based on what it has been learned. Whereas deep learning, it structures algorithm in layers to create an artificial neural networks. So that can learn and make intelligent decisions on its own. So in machine learning, we make some algorithm and we tell these machine learning what to do based on the input. But deep learning, it works on its own by identifying and making the decisions. So the machine learning have some simpler structures like linear regression and decision trees. So, but if it often require more human interventions. So, but deep learning, it doesn't require any human intervention. It has its own artificial neural networks, which are multi-layered and designed to mimic just like human brains. So these deep learning algorithms process vast amount of data, as I said earlier, and learn from it with minimal human guidance. So, but additionally, deep learning can handle unstructured data like images and text more effectively than machine learning. So, deep learning can also process complex data, and it is also capable of operating more independently than machine learnings. And um, it supports as we have the machine learning support some decision trees, some vector machines, but it is for less structured data like text and images, whereas neural networks tends to perform better while classical machine learnings techniques, we have gradient boosted trees, we have XGBoost and cat boost. This seems to have an edge for this tabular data. Okay. So this was the difference between deep learning, machine learning, and these are part of artificial intelligence. Like these are the subset of artificial intelligence. Now moving forward to the key concept of deep learning. Sorry, Yeah. So we have one core thing in deep learning that is called as neural network. So what is neural network is it's just like main node. So the main goal of this neural network is to minimize the cost of the function. And okay, just a second. So the neural network, they are just like the structure of human brain, and it is inspired by the human brain. So they are designed to recognize the patterns, learn from the data, make intelligent decision. So the basic unit of neural network are neurons, so which are also called nodes. So each neuron, it receives the input, process it, and passes the output to the next layer of the neurons. So I have some video for you guys, so that seeing that video you'll understand more what neural network I'm talking about is. So let me just talk to you about what it is, then I'll show you the video. So neural network has three different layers. One is input layer, uh, next is hidden layer, and third one is output layer. So input layer is the one where it receives the raw input data, and each neuron in this layer represent a feature of the input data. Next we have hidden layer. So hidden layer can be single and multiple. It depends on the complexity of the data which we are feeding it. Uh, so these hidden layers perform intermediate computations and transform of the input data. So a neural network can have multiple hidden layers, right? And it allows the model more complex relationship in the data. So what is output layer? Um this layer produces the final output of the network, which could be classification, a prediction, or some other decisions. There are also some weight and biases in neural network. So weight, it means it determines the importance of the future. Like if we are asking a neural network to identify a number one, and it determines the weight of that number in these hidden layers. So if the weight is more closer to one, then it will predict that one to the output layer. So how do we train the neural network? Like we train it by adjusting their weights and biases based on their predictions. So these process, we call it as training. Also we have an activation functions. This is another part of the neural network which is main function um, in predicting the output. So activation function are mathematical equation that determine whether the neuron should be activated or not. Yeah. So they introduce a non-linearity into the network, allowing it to learn complex patterns. Imagine a neuron in a neural network is like a light bulb. Whether the bulb lights up or not, it depends on the activation function. It's like on off switch for the bulb. So I'm speaking in simple terms how this activation function will basically work. Now think of inputs as wires connected to the bulb. Each wire sends some electricity. The neuron adds up all these numbers and adds a little extra, like bias. For example, now the activation function decides whether it should light the bulb, like switch on the bulb, or off it, or should it glow dim, or should it shine brighter. So the activation function actually transforms a total into an output that next neuron can use it. So without activation function, the bulb would just glow in a straight or boring way. So there's where this activation function plays an more important look. Like without activation function, also the neuron can work. But so, if we introduce activation function, it will give more precise output. So this makes activation function makes the neural network smart enough to learn complex patterns, like recognizing the faces, uh, predicting the weather. And these are like some examples of where we are using this neural sorry activation functions in neural network. So let me show you one video. Just with, it will picturize how this activation neural network works in picture. I'm just playing a video.
Suggests neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons, and admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16? Well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now, the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents.
So that was a visual interpretation of how neural network work. So that's how the data is processed in between the layers within the neural network when we are designing a deep learning mechanism. So now let me talk about some architects which we have in deep learning. So there are few different types of neural networks. So one is feed forward neural network, and I'll talk about all of them, how they have been used, and where actually we can implement all this. Like each of them will perform in a different manner. So these are the different architects of deep learning. So let me talk about the first one, which is feed forward neural network. So these are the type of neural networks where the information is moves in one direction, like it moves in only single direction without having any loops in it or any cycle in it. So the information is moved from input layer through the hidden layers and finally to the output layers, as we have seen in the video. So it's exactly the same. The input will flow from input, hidden layers, and the output. So there are no loops or cycles in the network. So that is why it is called feed forward neural network. So there are basic components are input layer, hidden layer, and output layer. So input layer is where the network receives the input data. For example, if you are trying to recognize some handwritten digits, so the input layer would receive the pixel values of the image. Then the hidden layers comes in picture after that. So it input layer passes the data to the hidden layers. Now these layers are where the network processes the information. So each neuron in the hidden layer takes input from the previous layers, applies its mathematical operations like weight, sum, biases, and then it passes the results to an activation function. The activation functions helps the network learn complex patterns, and then these data is passed to the output layer where the network produces a final result. Now, for example, in a digit recognition task, as we seen in the video, the output layer, it might have 10 neurons or multiple neurons. So each representing a digit from 0 to 9. So the network predicts is a digit corresponding to the neuron with the highest value. So how does a neural network worked is in this three layers: input layer, hidden layer, and the output layer. So in for example, in a real world, if we are using this feed forward neural network, it classifies the emails as a spam or not. So if you want to identify whether the email is a spam or not, we can use this feed forward neural network. So it actually identify certain keywords in the email, so just like the sender's email address and the email length, and then it passes to the hidden layers which processes these features, and then the output layer produces a probability score indicating whether the email is a spam or not. So these feed forward neural networks are widely used in various applications, including image recognition, speech recognition, and even playing the games. So this feed forward neural network can also be used to create some intelligent behaviors in games, like if a non-player characters, by training on various game scenarios. So these networks can learn to make decisions that mimic human-like behavior, and making the game more challenging and engaging. So they are also used in some pattern recognition, like such as player movements or strategies. So these helps in predicting player actions and adjusting the game difficulty accordingly. And so there are some procedural content generation also, so where they generate the game content such as levels, maps, and even storylines. So we FNN can be used in game testing also, like testing the process by stimulating neurons playthroughs to identify bugs and performance issues. So these speed up the development process and ensures a smoother gaming experience. So these was just about how we are using a feed forward neural network. There is another network called as recurrent neural network. So this is different from feed forward. So it is like working in a loop. For example, the name as suggests recurrent. So this is a neural network which is designed to recognize patterns in sequence of data. So like time series, speech, text, or even video frames. So unlike other neural network, so RNNs have a loops that allow information to be passed from one step of the network to the next, now making them ideal for tasks where context or sequential information is important. So RNN are like having a memory in neural network. As I said, it works in loop, right? So they can remember what they have seen before and use that memory to predict what might come next. So there are some like there are some problems which where we need RNN as important. Now, for example, uh, we have it in our keyboard also, right? When we type something, it will give pop up the next suitable word which matches to that sentence. For example, if you are saying like a cat is something like that, and it will predict uh, the next word to be animal, something like that. The cat is an animal. So just imagine RNN as a storyteller in talking about simple word. For example, if a storyteller, if he's telling any story, he should remember the plot of the story they are telling. If even if they forgot what happened earlier, the story doesn't make. So they should remember the earlier one in order to perform or in order to tell the story. So similarly, RNN keeps track of what it has processed so far. So as story progresses, the storyteller decides what to keep in memory, only the important events, and what to ignore it. So just like that, RNN keep the important events in the memory and ignore the less important details. So these are how this RNN works. It processes data one step at a time. Unlike the feed forward or other neural network, they process the entire sentence at a time. But RNN processing one word at a time, like maintaining memory of previous inputs through their internal state. So these memory allows them to make predictions based on their both current and past information. For example, like processing a sentence, RNN can use context of previous words to better understand and predict the next word. Now, what are the key components of this recurrent neural network? Similarly, we have input, output, and hidden layers. But in additional, we have neurons and layers, just like other neural network consist of neurons arranged in layers. So each neuron processes input data and passes the output to the next layer. So hidden have state that captures information about the sequence. So this is what it makes it differentiate from other neural network. It captures the information about the sequence. This hidden state is updated at each time, this each step, and helps the network remember previous inputs. So now we have loops. So the key feature of RNN is their loops, um, which allow information to persist. This means the output from previous state is used an input for the current step. Um, and as we have input data, the input data is fed to the network one time, like that is step at a time. And for example, in his sentence, each word is input sequentially. For example, a cat is so a is different step, cat is a different step, like similarly. Now there are hidden state which update at each step. The hidden state is updated based on the current input and previous hidden state. um, how the output is generated: the network generates an output each step. So these output can be used for various tasks, such as predicting the next word in a sentence or classifying the sequence. So there are some challenges with RNN. Like earlier, it it has short memory. Like RN struggle to remember long term dependencies, and also vanishing problem was there. So when training the new network has some trouble, like learning patterns from far back in the sequence. So the applications where we use RNN is text prediction, as I said. So whenever we are writing some text, it predict the next, what could be the next word. So like predicting the next word in a sentence. Also in speech recognition, in speech recognition, converting spoken words into text. Similarly, like Siri or Alexa or Google Assistant. Also, it uses in music generation, like composing music by learning patterns in notes and rhythms. um, and also translating sentence from one language to other language, just like we have Google Translator. So that's about neural sorry, recurrent neural network. Up next I have radial basis function neural network. So this is another type of neural network, and it is used for function approximation problems. So they are particularly used for tasks like classification and regression. Now, in simple terms, neural networks that's really good at grouping similar things together or predicting the value based on the pattern. So that's why it is called radial basis function, because the radial part refers how the RBF activation function responds to the input. Now it depends on the distance between the input and the central point. The closer the input is to the center, the higher the response is. That's how it works in neural network. um like in simple time, let me make you understand. Like imagine you are in a classroom with multiple group of students. Now each group represents a center. For example, study group for specific subject like mathematics. So when a new student walks in, um, imagine like this new student as an input to your group. Now you measure how close that student is to your group. Like are how close are to each group based on their interest. Like interest in the sense, it's like a distance. For example, the student is interested in English, so the distance will be very large, so it doesn't fits in your group. So that's how the RBFN decides which group the students belongs to, or predicts how well they are performed based on the similarity to the existing groups. Now this RBFN also have these three layers: input layer, hidden layer, and output layer. So the input layer receives the input data. For example, if you are trying to classify flowers, so based on their features like petals, length, and width. So these features are fed to the input layer, and then hidden layer, it contains RBF neurons. So each neuron has a center. Like it is different from what I have explained you till now. So it has some center neuron in the layer, and this calculates the distance between the input and its center layer. The neurons output is, if the neuron output is high, like if the input is close to its center, and low if it's far away. So the most common RBF used is Gaussian function. It's like an activation function which we have. So the example of this RBFN is example like classification of flowers. Imagine you have a data set of flowers with features like petal length and width, and you want to classify them into different species. So you train RBFN on this data set. The input layer receives the feature The hidden layer calculates the distance to the center of the RBF neurons, and the output layer combines this distance to classify the flowers into species. Um, so these RBFN are very powerful because they can model complex relationship in data while relatively simple structures. So they are particularly effective when the relationship between the input and output is non-linear. Um, yeah, that's what about RBFN. Let me move to another neural network, which is image classification with CNN. So CNN means convolution neural network. So this is the most important widely used nowadays neural network. So it's uses a special operation called convolution. So this operation allows the network to automatically and adaptively learn spatial hierarchies of features from input images. So CNNs are widely used in image and video recognition, recommender systems, and natural language processing. So CNN are very powerful because they can automatically learn to identify important features in images without needing manual feature extraction. So these makes them highly effective for tasks like image recognition and classification. Now, why CNNs are useful? Because humans recognize patterns. It's understand just like humans. So like how we can tell a dog from a cat, like if it is a dog or a cat by looking at their shapes. Like CNN learns to identify features like edges, curves, or textures from images, and also it automates the task. So instead of manually programming image recognition, CNN learn patterns from examples, so making them very flexible. So in simple terms, imagine you're teaching a child to recognize a dog. Now, what would be the first step? First step, look for basic features. So you make the child to understand the basic features, like you show the child the parts of the dogs, like ears, nose, eyes, which differentiate, like which are different from other animals. Now, similarly, CNN first identify these simple patterns like edges or corners. Then the next step is it combines all these features. For example, the child learns that combining these parts forms a dog. Parts in the sense eyes, ears, and nose. Now, CNN stack these features to recognize more complex patterns like the dog's face, and the final step, the child will decide whether it's a dog or not, and the child will say yes if it is dog and no, this isn't. So similarly, these CNN are useful um, uh, to make final predictions. Now the key component of CNN are, so it's slightly different from other neural network which I've seen till now, because it has a specific convolution layer. So what is convolution layer? So these layer apply a convolution operation to the input, so passing the result to the next layer. This operation helps in detecting features like edges, textures, and patterns in images. And there is a pooling layers. So these layer reduces the dimensionality of the feature maps, which helps in reducing the computational complexity and preventing overlifting. So the most common type is max pooling, which take maximum value from each patch of the feature map. Now there is fully connected layer. So after several convolution and pooling layers, the high level reasoning in the neural network is done via fully connected layers. So these layers are similar to those in traditional neural networks. Now, so now think of these convolution layer as a filter or magnifying glass. So it slides over the image, looking for the patterns like edges or colors. So the result is smaller, simple version of the image, highlighting only important features. So now pulling layer, this layer zooms out by shrinking the image. It helps reducing the size of the data and keeps only the most important details. Now imagine taking a photo and resizing it smaller without losing the key details. Now fully connected layer flattens everything into one line of numbers and decides what the image is. It's like taking all the features and making the final call, whether it's a dog, cat, or something else. Now, for example, let's say we have to build a CNN to recognize handwritten digits from images. So here it's how it works. It like as we seen in that video, the network receives an image of the handwritten digit, which is converted into grids of pixel values. Next, convolution layer applies a convolution filters to detect features like edges and structure. Then pooling layer reduces size of the feature maps while retaining the most important features. Then fully connected layer, the network uses the extracted features to classify the image in into one of the 10 digits categories. So there the real world example of this is, imagine you are using a CNN to classify images of animals. So the input layer receives an image. The convolution layer detects the features like fur, eyes, shapes, and the pooling layer reduces the complexity. And the fully connected layer classifies the image as a cat, dog, bird, or another animal. So these are the example how this CNN works. So the application in real life where we are using CNN is one is face recognition. A simple example is your phone lock, which recognize your face and it unlocks your phone. So there we have used CNN. Another is self-driving cars. Example, now we have auto self-driving cars which detects the signals, and the signs and the obstacles, and then it makes the decisions. Then we are using it in medical field also, like when scanning, where we need to find some tumors in x-rays or not. And also it is used widely in social media also. So that's why these CNN are powerful, because they can automatically learn to identify important features in images without needing any manual feature extraction. So these make them highly effective for tasks like image recognition and classification. So that was about convolution neural network. Uh, Next, I have it is generative adversarial neural network. So this is also a different network which we have seen till now. Like it operates in its own way. So because these GNs are fascinating types of artificial intelligence. So these can create new data and like which looks similar to the real data. So um, GNN consists of two neural network. One is called generator and discriminator. So that compete against each other. Now, uh, let's talk about generator. This generator, it creates a fake data. while discriminator tries to determine whether the data is a real or fake. Over time, both networks get better at their task, so resulting in generator producing highly realistic data. It's like a game where one side tries to fool the other, and like throughout this competition. So now, in simple term, imagine an art forgery game between a forger and an art critic. So the forger tries to paint a fake masterpiece. So the art critic, now forger, he here is like a generator. It tries to critic. It's try to create a fake masterpiece. Now the art critic is like a discriminator, so which inspects the painting to decide if it's a real or fake. Now over time, the forger gets better at creating convincing fakes, uh, like paintings, and the critic gets better at detecting the fake paintings. So eventually the forger creates fakes so good that critic can no longer tell the difference, and discriminator identifies it in uh, so well that it can precisely tell it's a fake image. So that's how these GNs work. So generator uh, takes random noise or inputs and generate fake data like images, audio, or text. And discriminator network, it evaluates the data and tries to distinguish between real data and the fake data. So real data is from the training set and fake data from the generator. No, there is some training process also in between. So that is the generator and the discriminator are trained together in a loop. So the generator tries to create the data that can fool the discriminator, while the discriminator tries to get better at identifying the fake data. So this process continues until the generator produces data that is almost indistinguishable from real data. So one example of this is image generation. Imagine you want to create a new images of 100 and digits. You train GN on datasets of real 100 and digits. Now the generator learns to create new images that look like handwritten digits, and the discriminator learns to tell the difference between the real and the fake digits. So eventually, the generator produces images that look just like real handwritten digits. So another example is like um, art creation. For example, GNN can be used to create new piece of art. By telling GNN on the data set of painting, the generator can learn to create new paintings in the style of the training data. So these can be used to generate new artwork that look like they were created by famous artists. So deep fakes of one of the most well-known application of GNN is in creating deep fakes. So by training GNN on dataset of videos of a person, so the generator can create new videos where the person appears to say or do things they never actually did. While these technologies can be used for entertainment, it also raises ethical concerns about the potential for misuse. Like for example, we have these AI apps nowadays, right, where we put a picture of someone in the video and it speak like as if the person is speaking. So it's an application where GNN are used. So that's why they are more powerful tools for generating realistic data, and have many existing applications in field like art, entertainment, and even scientific research. So the application where we are using these GNNs are it is using image and video generation nowadays. So were widely used to generate realistic images and videos, including creating new photographs of humans, cartoon characters, and even 3D objects. Then we have image to image translation, where genes can transform image from one domain to another, such as like converting sketches to realistic photos or translating satellite images to videos. And then we have text to image translation. For example, we have an AI tool where we add some text, like give me an imaginary photo of me walking in a Mars, right? So it will give you a image which suits you that situation that you are walking in a Mars. So that's how it converts the images based on the text given. Also in photo editing nowadays we have JNNs, and they are used for tasks like photo in painting, like filling in missing parts of an image, and also we have uh, like photo editing, facing face aging, like we can remove the age from the face, and we can apply some photo bending and all. Like these are the applications where nowadays we have used JNN, so it is widely used. And yeah, next last architecture which we have is natural language processing, that is transformer network. So this is widely used in translation. So as name itself suggests, it transform. So these networks are, they are type of neural network that are revolutionized and filed of natural language processing. So they're widely used in NLP. So the key idea behind these transformers is to process input data all at once. Like unlike we saw this recurrent, right, which was using word by word, but these transformer process the input all at once, uh, unlike the other models which processes data uh, in one step at a time. So these make transfer much faster and more efficient, so especially for tasks like understanding language and translating the text. So this transformer is designed to handle this sequential data such as text, and by learning the context and meaning of the data. So unlike the traditional neural networks, transformer do not process data in sequence, but instead use a mechanism called attention. So to weigh the importance of the different parts of the input data. Now the key component of transformer network is encoder and decoder. There are These are two components where the encoder processes the input data and generates a set of key value pairs, and it consists of multiple layers, each containing two main components: a self attention mechanism and a feed forward neural network. Feed forward neural network we have already seen in earlier slide. So now the decoder generates the output data by taking encoder's output and previously generated tokens as inputs. So it also consists of multiple layers as other neural networks. So each containing three main components. So one is self attention mechanism, encoder decoder attention mechanism, and a feed forward neural networks. So what is self attention mechanism? It's like a magic part. The model looks at all the words in a sentence and decide which ones are more important for understanding the context of each word. So, example, in a sentence, say, the cat chased the mouse. The word chased is most closely related to cat and mouse. So, the attention mechanism focuses on those words. As we see in feed forward layers earlier. Um, so now, what is this attention mechanism? So this is a core part of the transformer. It allows model to focus on different parts of the input data by assigning different ways to different tokens. So Self attention mechanism helps the model to understand the relationship between the tokens in the input sequence. So one example is machine translation. Imagine you want to translate a sentence from English to French. So the transformer network takes the English sentence as input and process it through the encoder. So the decoder then generates the French translation by focusing on the relevant part of the English sentence. So using the attention mechanism. So next, another example is imagine like text summarization in. So transformer network can take a long article as input and generate a concise summary. So the encoder produces the entire article and the decode generates a summary by focusing on the most important parts of the article. Also we have example of chatbots nowadays, so which transforms, I mean these are also a transformers which are used in chatbots to generate human like responses, like so whenever we are asking question, so we have some feeded answers which just chat like a human to the user. So similarly here the encoder will process the user's input message and the decoder generates a relevant and coherent response by understanding context and meaning of the input. So that's why, because transformers are powerful, because they can handle long range dependency and understand the context of the entire inputs sequence, making them highly effective for tasks like translation, summarization, and conversation generation. So they are widely used in these categories. Also it can be used in span detection, then sentiment analysis, and also machine translation, then question and answering chatbots, then text generation, and there is something called as named entity recognition, where this transformer can widely identify and classify entities in text, such as names of the people, organization, and locations. So these were the architects of deep learning. I'm over time, but I'll just finish how the deep learning works and where we are using it. So how deep learning works is, first of all, it collects the data. The first step is to gather a large amount of data. This data can be anything from images, text, audio, or any other type of data that you want to analyze. Then the next step is data pre-processing. Once you have the data, it needs to be cleaned and formatted. So these might involve normalizing the data, handling missing value, and converting data in a format that can be fed into a neural network. Next is building the neural network. So a neural network is made up of layers of neuron, as we have seen. So each neuron takes an input, process it, and passes it to the next layer. So the network typically consists of input layer, one or more hidden layer, and the output layer. So next is choosing the activation function. So each neuron in the network uses an activation function to determine whether it should be activated or not. So common activation function includes rectified linear unit, then sigmoid, and then tan. So these are different activation functions commonly used. Next we have next step is forward propagation. So in this step, the input data is passed to the network layer by layer. Each layer processes the data and passes it to the next layer until it reaches the output layer. Okay. The next step is calculating the loss. This is also the most important step, where the output of the network is compared to the actual target values using a loss function. So the loss function measure how well the network predictions matches the actual targets. So common loss functions include like mean squared error for recognition task, and cross entropy loss for calculation classification task. Another step is back propagation. This is a process of updating the weights of a network to minimize the loss. So the error is propagated back through the network, and weights are adjusted using an optimization algorithm like gradient descent. The next step is training the network. The forward propagation and back propagation steps are repeated for many iterations until the network's performance improves. So during training, the network learns to adjust its ways to minimize the loss. So the next step is evaluating the model. Once the network is trained, it is evaluated on a separate set of data, like a validation or test set, to see how well it performs on unseen data, like metrics like accuracy, precisions, recall, and this one F1 score. They are used to evaluate the model performance. And the last step is like making predictions. So after the model is trained and evaluated, it can be used to make predictions on new data. So these are the steps involved in deep learning. The next is the main component of deep learning. As we have seen, neural network uh, is a main component, and then data pre-processing is another component, where we train data by cleaning and normalizing. Then model training is another, the main in this, which where we train the neural network to learn from the data and adjust with based on the connection between neurons. And then model evaluation, like after training, the performance of the model is evaluated using separate set of data. Then the final component is deployment. Once the model is trained and evaluated, it is deployed for particular use. So these involve integrating the model into an application or systems where it can make prediction or decision based on the new data. So now next is the last part where we are using this deep learning. So in real world application. So it is widely used, like we have used in computer visions, like object detection for autonomous vehicle, self-driving vehicles. Then we have quality inspection in manufacturing. Also we use deep learning in control systems like robotics, smart manufacturing, and predictive maintenance. Um and next we use in signal processing, like noise reduction in signals and speech enhancement. We also use it in engineering, like civil engineering, where structural health monitoring using sensors and images. Urban planning using deep learning models for traffic predictions. Also we use it in electrical engineering, where it detects the fault, like fault detection in power grids, and also smart grid management. Then finally it has been used in mechanical engineering also, like predictive maintenance and anomaly detection in machines. So this fraud detection is also used in sorry deep learning is also used in fraud detection. As I said earlier, if we can detect the fraud transaction, and also the algorithm can identify security issues to help protect against frauds. So examples are banks. In banks we use deep learning to analyze transaction patterns and detect fraudulent activity. And in customer relationship management, so deep learning helps in predicting customer behavior, personalizing marketing effects, and improving customer service by analyzing large amount volumes of customer data, like as we surface the internet, or as we surface the products, it identifies what we are actually looking for. And in autonomous vehicles also, like as I said, self-driving cars. So there we have deep learning, which process data from sensors and cameras to navigate roads, recognize obstacles, and make driving decisions. So next, in medical science also we have deep learning, such as like it identify the cancers from x-rays and mris, and also it helps in analyzing complex medical data and providing accurate diagnosis. Another is it is widely used in speech recognition, like we have virtual assistants like siri and alexa, which are the use case of deep learning, and it helps understand and respond to voice commands. So these involves processing and interpreting natural language to perform tasks. And in healthcare also it is widely used, like medical imaging, healthcare data analytics, like in laboratory also, and also it like projecting our inner eye. So and also in patient care, like there are some chatbots that can check it with the patients before and after operations, to ensure they are well prepared and adjusting to their daily life. And also in drug discovery nowadays, so deep learning models, they can analyze vast amount of data to identify potential drugs and more quickly and accurately. So next, they have used in there's something called as genomic data interpretation, like where it is analyzing the genomic data, helping in understanding genetic variations and their impact on health. These can lead to personalized treatment plans based on an individual genetic makeup. So that's where widely deep learning is used on. So that's what all about. I had deep learning today. Like conclusion, it's the power of deep learning is huge. Like uh, it's at a next level. Like we have applied in real world application also, and we can explore more in deep learning. So there are some references also, which I would be sharing. You can go through this to understand more in deep learning. So I think if any questions are there, um, Kamya, I can take up, because I'm over the time, I know. uh, so Kamya, out there?
Thank you so much, Roxana, for an insightful session. I hope everyone has learned something today, and thank you everyone for joining us today on a weekend. So we'll meet you on the next session. We have our next session on next Friday. So see you all there. Thank you and have a good day.
Yeah, thanks, Azhar.
Thank you.
Thanks.